Okay, today is the last lesson that we need to learn about factoring before we start in on percents and decimals. We're going to use factoring to solve quadratic equations. And we're going to use something in mathematics that's very famous called the zero product principle. And what it basically says is, if two things are set equal to 0 that are multiplied together, then either A must be 0 or B must be 0. So anytime you have two things multiplied together to make 0, and you can think about that in your head, the only way that ever happens, it's one thing when you add two things together, like 2 could be added to negative 2 and get 0, but the only way two things are multiplied together to get a product of 0, one of them has to be 0. So we can carry that concept onto the idea of, say we had two binomials multiplied together to equal 0. Well, that means that x plus 2 has to equal 0, or x minus 3 must be 0. Therefore, we can solve and say either x is negative 2, or x is 3. It only works, though, when we have 0 on one side of the equation. So, one more like this. Let's say we had 2x minus 7 and 3x plus 5. Multiplied together must be 0. That means 2x minus 7 is 0, or 3x plus 5 is 0. So 2x is 7, x is 7 halves, 3x is negative 5, or x is negative 5 thirds. And we take it one step farther, and let me give you a factorable trinomial. But now I'm going to turn it into an equation by setting it equal to 0. Well, a lot of time you're used to trying to get x by itself, but since you have both an x and an x squared, that's not going to be possible. So instead, we're going to turn to the zero product principle to help us. Let's focus on the left side of the equation first. That is a factorable trinomial. And if we use a sum and product chart, you should be able to see that's x plus 3 and x minus 1 have to equal 0. So then we can say, okay, well then, if we set those accordingly, we must solve that x can be negative 3 or positive 1. We actually can solve a quadratic equation by factoring and using the zero product principle. And it works for all different types of factoring that we do. So let's put this one up on the board. So we're looking for a sum of 5 and a product of negative 24. Okay? Back to the sum and product chart to factor this trinomial. I believe positive 8 and negative 3 are the numbers that multiply to make negative 24 but add to make positive 5. So just like we've done in the past, we bring down the 2x squared, we bring down the negative 12, and then we can do a positive 8 here and a negative 3 here to make the 5. Do our GCF. And we get 2x minus 3 times x plus 4 equals 0. So, just repeating what we've already done, we've got a perfectly good trinomial that was factorable. We factored it into two binomials multiplied by each other, but now since we have an equation and not an expression, we can set them individually up to equal 0 and solve. We're solving quadratic equations by using factoring. Pretty cool stuff. And it works not only on just factorable trinomials, but take, for example, this problem. What's the first thing we always look for in factoring? Well, we look for a GCF. And here's the neat thing about equations. We can divide both sides by 4. And that 4 just goes away, right? Because 0 divided by anything is still 0. That's the difference of two squares. So x plus 2, x minus 2 equals 0. So x must be 2 or negative 2. You can also see this with perfect square trinomials work the same way. That's a perfect square trinomial. Square root of this term, square root of this term, multiplied together times 2 equals that. And it factors into square root of the first term, sine of the second term, square root of the third term, squared. So x minus 3 squared equals 0. So x minus 3 equals 0. So x must be 3. What if we see an equation that looks like 2x squared minus 12 equals negative 5x? Well, the key to that is we don't have 0 on one side of the equation, so we can't use the zero product principle. So we're going to have to bring that 5x, by adding 5x to both sides, to the other side. And then this one's similar to the problem we just had that factored into, we had 2x squared plus 8x and negative 3x minus 12 equals 0. And you know the rest from here, x plus 4, negative 3 times x plus 4. Got an extra parenthesis in there for no reason. X is going to be 3/2 or negative 4. And you won't see this much, but there's no reason it has to be two terms. If I had some crazy equation like this, well, no big deal. All these things multiplied together have to equal 0, which means one of them's got to be 0. So you can come up with 2, 0, negative 5, or positive 4. That's it.